Hello and welcome to lesson 7.1. We are starting our unit on stoichiometry today. And I assume that you know by now, because I've probably said it 100 times, that stoichiometry is really like a recipe for a chemical reaction taking place. So, any and all chemical reactions that take place have a chemical recipe that we are going to learn how to read during this unit. We're going to start with an easy example of here we have a s'more. And like it says here, you can think of the reactants, remember that's the left-hand side of the equation, as the ingredients. So they are the things that are being mixed together to create the product, which is what is on the right-hand side of the equation. So reactants, ingredients, product, end result from whatever chemistry cooking that is going on. So if we were going to write the recipe or the chemical equation for making this s'more, it would look like this. So GR, like it says here, is graham cracker. So we've got 2 graham crackers, right? 1 square of chocolate and 1 marshmallow makes 1 graham cracker. Okay, so that's the recipe, and we can expand that however we need to make more s'mores depending on what we need, right? So that is the recipe. So we can use that recipe, as we learned in the last lesson, to come up with ratios to figure out exactly how much of everything that we need. Here's how that's going to work. So here's our example problem for this formula. It says if you have 576 graham crackers and an excess of chocolate squares and an excess of marshmallows, which means we have more chocolate and marshmallow than we will ever need. So we will not run out of chocolate or marshmallows. The first thing we're going to run out of is graham crackers. So how many s'mores can we make with 576 graham crackers? I understand you can just do that in your head, but let's work through the process, because when we get to later on talking about moles and other chemical reactions, you're going to need to know the process. So here's kind of the process for doing that. First, we write our mole ratio. All right, so that's our first step. We're going to write our mole ratio. This case, like it says, you're using items. But from our chemical reaction, we are going to write our mole ratio. So the top of the ratio, we write what we want. How many s'mores can you make? So our desired product is the s'more. 1 is the number that goes with the s'more, because that's the coefficient, right? The reactant, or the ingredient that we are looking at, is the graham crackers. And the coefficient on graham cracker is 2. So 1 s'more made from 2 graham crackers. Okay. So there we've come up with our ratio. Next step is we make our little math problem, right? So we are given in the problem that we have 576 graham crackers. So 576 graham crackers. Then we write down our ratio, 1 over 2. That came from these coefficients out in front here. That's where that number came from. And then we solve our problem. And I know you're thinking, well, in my head, I just did 576 divided by 2, and I got the answer. But again, we need to know the process, right? So it becomes important to know the process when doing more complicated problems. So 576 divided by 2 is, hang on a second, I got to do it in my head. 288. 288 s'mores. Oh, let's actually use the chemical formula for that. Gr2CHM. So we can make 288 s'mores if we have 576 marshmallows. Graham crackers, and an excess of everything else. Please read this. Well, okay, I thought my time was going to run out, so I will read it for you. I thought it was going to stop me at 5 minutes, but it's not. So, why is this important in chemistry? This is important in chemistry because scientists use it to get these ratios. So, a couple of things. They can predict the amount of a product that will be produced. So, if I'm working in the industry and I need to know, okay, I have this much ibuprofen powder, how many Advil can I make with that? Right? It's done. I've done it. Right? So, you can predict the amount of product that you'll get. They also can go the other direction and predict the amount of ingredients they need to get a certain amount of product. If I have a client come to me and say, I need 7 million aspirin tablets, well, do I have enough materials to make that? You can use the chemical equation to figure out and predict how much of all the ingredients you'll need to get their 7 million aspirin or whatever it was that I said. Okay. So this stoichiometry process that we will be learning through this unit is the most practical thing that chemistry is used for in industry to predict product or predict how much ingredients that you will need to make a certain amount of product. Hugely practical, hugely important.